doing all the work for everybody, huh? What a nice guy. Okay. How many of you remember from Algebra 1 that you did the quadratic formula? Do you remember having to do that? I honestly don't know, like at the end of the class, is probably when you get to the quadratic functions and solving using the quadratic formula. And my bet is that some teachers really don't do much with it. Focus on more linear kind of things. But that we definitely do a lot with quadratic formula in this class. I think this is probably the level where you get the most learning of quadratic formula. And the quadratic formula is a strategy to solve quadratic equations, basically. We already learned two. We learned solve by factoring, solve by graphing. And this is a third, which is solve by quadratic formula. And so we have to, that's the first bullet here. The second one, we will learn, there is a part of the quadratic formula which has the name discriminant. And it's not the whole thing, but if you can just calculate that number, it tells you about what kind of answers you should get, which is, these are SOL objectives. Do you have a question? No, we're going to do our lesson, always do a quiz at the end, hopefully by 25 after, depending how it goes. So the quadratic formula, okay, like both of the other methods that we talked about, you start with having a quadratic equation that has 0 on one side, right? And what's on the other side, it's got to be, again, what we call standard form. It's got the square term, and then the x to the first term, and then the constant term in order. Okay, the A, B, and C, those are the coefficients of those terms, meaning the numbers in front of the variables or the constant at the end. They do not include the x's. They just are the numbers. And if you have your equation and you can identify what is the value of A, what is the value of B, and what is the value of C, then this is the formula you plug it into, and it solves the equation for you. Uh-huh.
I'm not sure, but I think we're going to have to remove this whole formula. Is that true?
No, it's given to you. So this formula, it always works. But we're going to find out there are times, there are quadratic expressions that are not factorable. So you're not going to be able to solve by factoring. There are quadratic equations that if you look on the graph to see where it crosses the x-axis, it doesn't cross the x-axis. So you're not going to be able to solve it that way. And for those situations, only the quadratic formula works. So it's the only method that always works. And it's given to you on tests. All the tests I give you, I will give it to you. It's on the Algebra 2 SOL formula sheet. So you're going to have it on the SOL. You do not need to memorize it. You just have to know how to use it. Okay. And if you do, it solves a lot of problems for you. I mean, in the end, you'll find that there can be an equation that you're given that it's factorable. It really is factorable. But if you can't think how to factor it, you could still put it in the quadratic formula and solve, right? You don't actually have to factor everything. You know, this is an example of use the quadratic formula to solve. Okay, so am I ready to identify my A, B, and C looking at the equation that I'm trying to solve right here? Because why? It's got to have a 0 on one side. So what would we do, probably? Add 12. Okay, so this is going to be x squared plus 8x plus 12 equals 0. Okay, once you've got it in the standard form, that form right there, then you can identify what are your values of A, B, and C. Right? A is the number in front of x squared. Okay? If you don't see a number in front of x squared, it's 1, right? Because we generally don't write a 1, but it's there. Right? So you say A is 1. What is the value of B? 8. And what is the value of C? 12. Okay, so those are the numbers that you're going to plug in to this formula. Okay? So let me go ahead and plug in. X equals negative 8. And then this plus or minus, right, we're going to have that symbol is part. It means that we're going to have two answers. One you'll get if you add what follows, and one you'll get if you subtract what follows. Yeah? The X equals what? The formula has a negative in it, and B equals 8. So I was saying negative B is negative 8, right? Plus or minus the square root of B squared, 8 squared, minus 4 times, and the 4 is part of the formula, the A, which is 1, and times the C, which is 12. All right, and divided by 2 times A. Don't ever forget the denominator. That's a very common thing. You just work with the numerator, you forget you're dividing by something. This is 2 times 1. Okay, once you've got it in there, then it's time to simplify. And simplify is mostly order of operations stuff. Other than the fact that when you dealt with order of operations, most of the time you didn't have a square root to deal with. Right? In PEMDAS, there's nothing about square roots. So let's see how this works. Negative 8 plus or minus the square root of 8 squared is 64, minus 4 times 1 times 12 is 48, divided by 2. So let me come over here. So X equals negative 8 plus or minus the square root of 64 minus 48 is 16. And luckily, 16 is a perfect square. What is the square root of 16? 4. 4. Okay, so now we've got negative 8 plus or minus 4 divided by 2. So now we've got to deal with the plus or minus, right? It means we're going to do this calculation twice. Once will be negative 8 plus 4 over 2. And then another time will be negative 8 minus 4 over 2. Right? Do it twice. What is negative 8 plus 4 over 2? Negative 8 plus 4 is negative 4. Negative 4 over 2 is negative 2. Negative 8 minus 4, negative 12. Negative 12 over 2, negative 6. Did anybody try to put that in a calculator and not get that? For example, like on this one, do you say negative 8 plus 4 over 2, and maybe you got negative 6. You have to remember what's in the numerator would have to be put in parentheses. Right? Otherwise, it's going to do negative 8 plus 4 over 2. Right? And that would be wrong. Now, we could have done that easier by factoring. Right? At this step right here, it's a simple quadratic. What are the factors of 12 that add up to 8? 2 and 6. X plus 2 times x plus 6. So the answers are negative 2 and negative 6. That's it. But if even that kind of, knowing your multiplication tables is a challenge, again, if you have this in front of you, then you could always plug in. Maybe that'll be hard also in its own way, right? But you have some options. A couple things to keep in mind here. That divided by 2a, usually when you say the quadratic formula, the way you say it, you go negative b plus or minus the square root of b squared minus 4ac all over 2a, meaning everything up there is being divided by the 2a. It's not just the square root, right? And the 2a is not inside a square root. So you can't try to combine, let's say this 2 into 16. No, you can't do that because the 16 is inside the radical and the 2 is not inside the radical, right? You can only use that 2 with things that are outside the radical. Yeah,
And then we would just like order that and calculate it.
I'm going to show you in a second. Okay, now what's the difference between that problem and that problem? The A is 1, the B is -8. On the first problem, it was +8, right? So let's see how this would work with just that one difference, because this is where we make a lot of mistakes with the quadratic formula, right? So here we'd say A is 1, B is -8, and C is 12. All right, then I put in the quadratic formula. X equals -8, right? Because that's -8, but there's a negative in the formula, plus or minus the square root of -8 squared minus 4 times 1 times 12 all over 2 times 1. Okay, now, what do you get if you try to simplify what's inside the radical? -8 squared is, put in your calculator, what do you get? What's next? It's positive 64 because you have to remember to put it in parentheses. That's a common mistake that we make, right? Sometimes a -8 would cause a little bit of trouble. If one of the A or the C is negative, that causes trouble sometimes too. Then you got to think, well, that's going to be minus a negative, which makes it a plus. There's a lot of places to go wrong with this when you're just trying to simplify the quadratic formula. For that reason, I would recommend, it won't work for everything, but it actually works for quite a lot. Do it in your calculator, and I'll show you how you do it in a calculator using the things that we talked about on day 1. Remember how we learned to store values for the letters and then just type in the letters, right? You can do that, and it'll work. I mean, let's say on this one here, I can tell you what the answers are going to be, right? This is going to be x minus 6 times x minus 2 equals 0. So x equals 6 and x equals 2. Those are the answers. Okay, let's see how we can do this in the calculator now. Let it do the whole thing for you. Okay, and let's see. I got to clear that off. Okay, so first we need to store the values. A, B, and C. How do I store A equals 1? Remember, first you say the 1. 1, then you hit the store button, which is right here, which gives you a right arrow. And then where do you find the A? Right, it's on top of the math. It's the alpha. You got to hit alpha first. So you go alpha, math, and now hit enter. It's not done until you hit enter. Right? So now the calculator thinks A is 1. Okay, now store B equals -8 and C equals 12 in the same way. So -8, store, alpha B, enter. 12, store, alpha C. That didn't work. Store, clear. 12, store, alpha, C. There we go. Now, here's where you bring up the fraction format that the calculator has that we didn't know about until like right before the SOLs last year. But it helps a lot. Otherwise, when you enter this formula, you got to be extra careful about parentheses everywhere. But if you just know where to find the fraction format, which is this way, right? You go alpha, y equals, and what you see is this little menu here, right? The very first one, n over d, is numerator over denominator. That's a fraction. So you just hit 1. And now it's giving you the fraction to enter this formula. So you won't have to worry about getting the numerator and the denominator in parentheses. That part's taken care of. So now we have to enter the quadratic formula, which I'm going to go back to, I'm going to do it here because so I can have it on the calculator. So there's the formula. The thing is, you don't have any way to do plus or minus. So you're going to do plus, enter, then you'll do minus, enter. You get your 2 answers. So let me do, I'm going to do the plus first. Okay, negative alpha b plus the square root, second square root. Can you bring up that symbol? And now you're inside, you got to do the b squared. So alpha b squared minus 4, and you don't need parentheses for this, right? You could just say 4 alpha A alpha C. Right? And then right arrow to get outside of the square root. And then right arrow to go down to the denominator. And now put in your 2A. 2 alpha A. So that looks like the quadratic formula, right? And now it's going to evaluate it. Yes. Right arrow until you get to alpha y equals 1. Okay. So when I hit enter, it's going to evaluate the plus side of the quadratic formula, and it gives me 6, which I knew was one of my answers. Right? Okay, now to do the minus side, you need to bring up the formula again. So the way you can bring up something that you've already typed in without having to retype it is just go second, enter. That will bring up the last thing that you typed. And now I can scroll over the top of that formula until I get to the plus and make it a minus. So there, I'm right over the plus. So now I hit minus, enter, and the other answer is 2. So with that, you'll never make a mistake on is negative 8 squared, positive 64, or negative 64. Or if you've got minus 4AC and either A or C or both is negative, what happens to that? The calculator takes care of all that for you. Right? So remember that. Now, let's do another problem here. We did that, we did that. We just did, I only put that one up to show you how it gets more complicated when you got negatives flying around, right? And why the calculator really can't help you with that. Okay. Now, let's say that I wanted to solve this one. 3x squared plus 2x minus 1 equals 0. I mean, that's a factorable problem. But what kind of factoring would you have to do? Because that's not a 1. You're going to do that not simple, which is like 5 or 6 steps, a lot of places to go wrong. You can always use the quadratic formula. And I don't know if I said this already, but like when I was a kid, when I was your age, we never did that long, not simple thing. Never. If you couldn't just do it easily, the simple quadratic, we just put it in the quadratic formula. Right? We didn't spend any time, I don't remember ever doing that. And so like something like this, you'd probably rather do quadratic formula, especially if you know how to do it in the calculator, right? So what are my values here of A, B, and C? What are the values of A, B, and C? A is 3, B is 2, C is negative 1, which again, you could put it in the calculator like this. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 1 divided by 2 times 3. Right, so x equals negative 2 plus or minus the square root of 4. And what's going to come next? You know, that's a minus 4 times 3 times negative 1. That's not a very good negative 1. Right? That's going to be like minus a negative, which makes it a plus. So it's actually plus 4 times 3, 12. Another place where we can have problems.
So, the change it, you just talking about the original.
I'm not sure what you're talking about.
When you said it's going to change it to a plus.
If you're simplifying it, you know, without using the calculator, you have to turn that minus into a plus. It's got to be end up being 4 plus 12, not 4 minus 12. That would be a problem.
So are we ever going to have to use any class
You might. I'm not going to say never, but I'm teaching you this for a reason, so that I want you to know how to do this, so you don't make mistakes with this. So if I follow through with this one will be x equals -2 plus or minus the square root of 16 over 6, which is -2 plus or minus 4 over 6. So you're going to have two of them, right? -2 plus 4 over 6, which is 1/3. And you're going to have -2 minus 4 over 6, which is -1. Okay, now let's say I'm going to do it in the calculator, right? I can bring up that formula without retyping it. It's already in the calculator. All I got to do is restore A, B, and C, right? That's all I've got to do. So let me restore. A is 3, B is 2, C is -1. Right? 3 store alpha A. 2 store alpha B. -1 store alpha C. And then I'm gonna keep doing the second enter until I get the quadratic formula back on the screen. Second enter, it brings up the last thing I typed. Second enter, it brings up the thing before. Second enter, second enter. Okay, there's the quadratic formula. Rerun it. -1. That was one of our answers, right? I don't have to put it in again. It's already in there. But once you've got it in there once, you're good. Second, enter. Bring up the quadratic formula again. This one had a minus. Change it to a plus. Rerun it. So scroll back over. There we go. Plus. Enter. 1/3. Okay. Okay. Okay, so we need to move on. Okay, so let me do this one. Solve using quadratic formula. What do I have to do to this one before I start? I got to have 0 on one side, right? So I'm going to add x squared to both sides so that it looks like x squared plus 6x minus 5 equals 0. Okay, so now let me run the quadratic formula. I'm not going to write down the A, B, and C because I can tell 1, 6, -5. X equals -6 plus or minus the square root of 6 squared minus 4 times 1 times -5 over 2 times 1. X equals -6 plus or minus the square root of 36, and then it's minus times a negative makes that a plus 20 over 2. X equals -6 plus or minus the square root of 56 divided by 2. Now, is 56 a perfect square? No. So you have to simplify it without turning it into a decimal. If you try this one in the calculator, just store the values like I said and then let it do the quadratic formula, it's definitely going to turn everything into a decimal. Now, on my test, I'll let you do that, but you need to be able to recognize an answer when you see it expressed as a radical, as a square root, because that'll be how you see it on benchmarks and the SOLs and things like that. 56, the square root of 56 is not a perfect square, but actually it has a factor of 4, and 4 is a perfect square. And unfortunately, not next chapter, but the chapter after that is all about square roots and things like that. We will learn how to do square roots better than we probably know right now. So the square root of 56 is the square root of 4 times the square root of 14, and since the square root of 4 we know that's 2, then we simplify it like that. 2 times the square root of 14. So that makes this x equals negative 6 plus or minus 2 times the square root of 14 divided by 2. X equals, and now this 2 divides evenly into 6, and it divides evenly into 2, so we factor it. Negative 3 plus or minus the square root of 14. Right, which means there's your two answers. Usually you're just going to leave it like that. There's two answers, done. You don't have to turn it into decimals or anything. If you did, if anybody stored the A, B, and C, and you see what you got, then you'd know, here's your two answers. Negative 3 plus the square root of 14, and negative 3 minus the square root of 14. You could turn those into decimals and see if they're the same decimals as you got when you put it in the calculator. Okay, let me proceed because I want to finish this in about the next 5. If I did this one, this is a perfect square trinomial. So I'm not going to go through this just to save time, but this, if I factored it, it would be like this, right? 2x, well, I think I'm going to have to do it anyways. 2x plus 3 squared equals 0. So we could say that x is going to equal negative 3 halves, right? If I plug in over here, I'm going to get x equals negative 12 plus or minus the square root of 12 squared minus 4 times 4 times 9 divided by 2 times 4. X equals negative 12 plus or minus the square root of 12 squared is 144. 4 times 4 times 9 is 144. So x equals negative 12 plus or minus the square root of 0 over 8. Well, what's the square root of 0? It's 0, right? Which means when you add or subtract the square root of 0, you get the same number, right? The answer is going to be negative 12 over 8, which is negative 3 halves, which is what I already got by factoring. That's what happens when you have a perfect square trinomial. You're going to end up with what's underneath the radical. It's 0. So you get the same answer whether or not you add or subtract. You get the same answer from the quadratic formula. Okay. So what that tells us is what's inside the square root tells you how many solutions you should expect. Right? If that number is greater than 0, you get 2 answers because you're adding or subtracting a real number from the first number. If that number is 0, you get 1 answer because you're adding and subtracting 0 from the first number. That expression right there, b squared minus 4ac, is called discriminant. Right? That's an important vocabulary word, discriminant. So knowing the value of the discriminant tells you how many solutions to expect. All right, so here's our 3 possibilities. This is the discriminant. If it's greater than 0, you expect 2 answers. If it equals 0, you expect 1 answer, which leaves one more possibility. What if it's less than 0? Right? If it's less than 0, you don't get any answers. You would eventually we'll have a solution, but right away we would say no solution. Right? Graphically, because we know how to solve by graphing, when the discriminant's greater than 0, your graph crosses in 2 places. That's why you've got 2 answers. When your discriminant equals 0, the graph actually just touches in one place and goes back the same direction, so it just has 1 answer. And when the b squared minus 4ac is less than 0, it means the graph doesn't cross. Right? It has 2 answers, but they're not real numbers, and that's the next lesson that we do. So this is a graphic from your book. All right, so you're going to have some homework problems that say evaluate the discriminant, okay? When it says evaluate the discriminant, it means don't do the whole formula, just do the b squared minus 4ac part, right? B squared minus 4ac. Right, well, in this problem here, what are the values of a, b, and c? 1, negative 4, negative 5. Negative 4 squared minus 4 times 1 times negative 5. 16 plus 20 equals 36. So the evaluate the discriminant part, 36. That's your answer. Okay, the part that says how many real solutions is where you take that number and you go back to the table. 36 is greater than 0. How many real solutions? 2. Right, simple. Same thing. Do the b squared minus 4ac. B squared minus 4ac divided by 2a. Divided by. We don't need all that. B squared minus 4ac equals 1 squared minus 4 times negative 2 times negative 28, which is 1 minus, because that's a minus times a minus makes that a plus, and 2 times 28 is 56. 4 times 56 should be negative 230, if I'm right. 56, 4 times 50, 200, 4 times 6, 3. Minus 230. So this is negative 229. So that's the evaluate the discriminant part. How many real solutions do you expect if the discriminant is less than 0? 0. Right? That's that last one. Right? The discriminant was less than 0, no real solutions. If we graphed it, wouldn't cross the x-axis. Right, so it's 2 real solutions. No real solutions. Okay, so that's the homework.